This slide is from my baseball think tank Palooza 2017 presentation, and I think it's an important slide because it addresses how the body is able to generate power that the muscles should not be able to generate. And what I mean by that is that the fastest known human event, as far as from my research, from what I know, is the external to internal rotation of the shoulder. It can take place, the speed of that rotation can be as high as 9,000 plus degrees per second. What's interesting about this slide, and in particular the article, this came from a research article entitled Elastic Energy Storage in the Shoulder and the Evolution of High-Speed Throwing in Homo. Now, Homo, first impression may not be the right the word that you would think it is. It actually stands for Homo sapiens, meaning man. And it talks about the evolution of throwing over, from time zero. But anyway, the key point of the research or the article was the calculation of how much energy is required to generate high-speed external to internal rotation. And if you follow me, you can follow me. What the study has done is they've started from a physiological standpoint in terms of how the internal rotation is being powered, and they start off by determining that from research that the average amount of power that skeletal muscle can generate in terms of watts per kilogram of muscle mass is approximately 250 to 500 watts per kilogram. And then what they've done is added if you want to call it for best, what we call it in the engineering community, a fudge factor, saying that due to stretching creates force enhancement, potentiation effect, eccentric, so on and so forth. They're giving it a 1.75 multiplier. So the maximum, what they call the maximum modeled muscle power, skeletal muscle in terms of watts per kilogram, ranges from 438 to 800 watts per kilogram. And then what they've done is a calculation for shoulder rotation during acceleration. This is specifically for going from external to internal rotation. And they're saying that the calculated amount of energy required to do that is approximately 132 plus or minus 52 joules. The time that happens, and as this is consistent with what I said previously, that it happens very, very fast. That time, and this is again quantified from measurements, is 0.034 seconds. In other words, 34 milliseconds plus or minus 13 milliseconds. The average joint power during that time is 3800 plus 3847 plus or minus 1967 watts. Estimated total muscle mass of the shoulder to generate that amount of or to creating that rotation is 2.16 kilograms. Now if we take 2.16 kilograms and we multiply it times the maximum 800, it comes out to roughly 1728 total watts that can be generated by the muscle mass. Now what they've done also is to basically assume the largest amount of muscle mass for this particular example in the shoulder area to create internal rotation. The what we also have here is that if you go by, they've calculated joint power, that the actual power necessary to create that kind of internal rotational velocity is 3,847 plus or minus 1967 watts, which comes out to be, to generate this kind of internal rotation, your muscle capability would have to have 1,781 plus or minus 900 watts per kilogram, whereas their only maximum from literature is 800 watts per kilogram. So we're about the maximum power that the muscles can produce is about half of what would be required to generate that internal rotation. So where does that additional power come from to create that very, very fast internal rotation? It's believed that it comes from the elastic energy that's stored going from when you're initially going high into rotation, meaning what happens is the forearm lays back, you have external rotation of the shoulder, the nominal volitional rotation of the shoulder, external rotation shoulder, about 125 to 130 degrees. So you have another 50 plus degrees, 40 to 50 plus degrees that can't be accounted for with volitional, and is what allows that to happen without without pulling the shoulder apart is the connective tissue, which has significant elasticity. So that additional power to generate internal rotation is hypothesized as being due to elastic energy that's released going from external to internal rotation. And another slide that can be used to help understand, support the hypothesis that it's elastic storage of elastic energy from external to internal rotation can be hopefully shown on this slide. This is basically, one of the things that's bothered me from day one is the muscles are only capable of generating rate of force at a certain rate of force. The faster you try to generate force, the less force you can generate. And this is what's depicted in this graph. What's shown here are three different muscle rate of force development capabilities based upon the type of training that the muscles have been exposed to. The blue line, solid blue line, is untrained. The dotted line is heavy resistance train, and the orange dashed line is explosive ballistic train, typical of underload, overload training, plyometric training. And what I've done here is shown that in this case I did 50 milliseconds because 50 milliseconds I was looking at in this particular for this particular slide is how long the body's actually applying or in contact with the baseball when it's throwing it, how long the hand is in contact with the baseball. And it turns out it's about 50 milliseconds. So during that 50 milliseconds, this is where we are if the person is throwing the baseball has been subjected to heavy training, heavy resistance train. They can generate during that 50 milliseconds, or at the end of the 50 milliseconds, they are here on the rate of force developed. This is force axis, this is time axis. For a ballistically trained person, the explosive force is here. So you can see it's almost a 2-to-1 difference based upon these curves. But still, the problem is, as I tried to outline in the previous slide, is that there's just not enough muscle mass powering the shoulder to generate that kind of force in that short a period of time. Don't forget, for the training or for the external internal rotation and internal rotational speed, we're talking about less than 50 milliseconds. We're talking maybe around 30 or so down here. So your levels are much closer. They're only in this area right here. You simply, based on this, you simply don't have enough muscle power to generate the force necessary to generate external to internal rotation via muscle mass alone.